Hello everyone, welcome to VLSI Academy. This is lecture 33 and today we will understand about the concept of OCV, that is also called as on-chip variation. This is a multi-part video. In this first part we will understand about introduction and definition of on-chip variation concept, and in the later videos we will go and further deep dive into the concept and how do we implement OCV. Alright, let's get started. After a chip is manufactured, process and environmental parameters may not be uniform across different portions of the die. Due to process variations, identical MOS transistors in different portions of the die may not have similar characteristics. These differences are due to process variations within the die. In this section, we will analyze the process variations across one die. These are called as local variations, which are much smaller than the variations across multiple manufacturing lots across different dies. That is called as global process variations. Besides the variation in process parameters, different portions of the design may also see different power supply voltage or the temperature. It is therefore possible that two regions of the same chip are not at identical PVT condition. These variations are referred to as on-chip variation, that is OCV. And these variations can affect the wire delay and the cell delay in different portions of the chip in a different manner. Modeling of OCV is not intended to model the entire span of PVT variation possible from one wafer to another, but to model the PVT variations that are possible locally within a single die. The OCV effect is typically more pronounced on the clock path as they travel longer distances in the chip. One way to account for the local PVT variations is to incorporate the OCV analysis during the STA. Since clock and data path can be affected differently by the OCV, timing verification can model the OCV effect by making the PVT condition for launch and capture paths to be slightly different. The STA can include the OCV effect by derating the delays of specific path. Now coming to the types of OCV. There are three types of OCVs. In the initial days of VLSI, OCV was sufficient to model the behavior or variation of transistor across the chip. But as VLSI progressed, this method of modeling variation was inaccurate because of many different reasons. One reason was with increasing complexity of the chip and with increasing functionality which was being put into the design, logic depth kept on increasing, and hence the model variation was not correct anymore. Hence, advanced OCV was introduced, which is short form for AOCV. However, in the latest design, this methodology is also found to be pessimistic, and nowadays we use parametric OCV, which is based on the statistical variation of the transistor across the chip. How these are modeled and how delay calculation is done in each case, we will see that in upcoming videos. That's all for this video. Please like, share, and subscribe to the channel, and please do give your feedback in the comment section. Thank you.